Hey everyone, welcome back. We're going to go ahead and start now on to the next section. So 10.4, parametric equations. Our essential question today is, how do I sketch a plane curve represented by a parametric equation? So most of you should probably have never heard of parametric equations. And basically, they're a different way to represent, well, equations. Okay, so normally it's something like this, where we have y equals negative x squared over 72 plus x. Well, that's going to be a quadratic equation. And we know how to graph those. Essentially, it comes out to some parabola looking like this with x and y. So let me just write it for reference again. Y equals negative x squared over 72 plus x. And that's going to come out looking something like that, where basically for every x value we have some y value, and in this case x might be distance away from a starting point and y might be the height. So based on these equations, I might be able to say, okay, if I threw a football into the air about 20 feet away from me, it should be 30 feet in the air, something like that. However, parametric equations introduces a new variable into this, and that variable will become t. And in other words, t is going to stand, for the most part, as time, and this is going to represent something called a parameter. By including t, we're creating this thing called a parametric equation, where now we account for time. So at 1 second, we might be a certain distance at a certain height. At 2 seconds, we might be at another distance at another certain height, where it ends up looking something similar to this, where at 1 second we're here, 2 seconds, 3 seconds, so on and so forth, all the way to 8 seconds. So in other words, we're graphing according to time. All right? We're still using units like this, distance, height, time, etc., but we're introducing this so it counts as like almost a third variable. Okay? If you want to read up a little more about it, there is an intro right there, but let's go ahead and continue. What I want you guys to copy down is that highlighted section. So definition of a plane curve. If f and g are continuous functions of t on an interval I, then the set of ordered pairs, blah, 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 plane curve, so on and so forth. Make sure to copy all of that down. Okay. So moving on from that, the only thing we're going to be doing today is sketching the parametric equation, which will come out as some sort of curve. Okay. So example 1. We're going to sketch this equation that's represented as x equals t squared minus 4, y equals t over 2, and our parameter tells us that we're going to be between negative 2 and 3. Now some of you might look at this and say, wait, how can we have a time of negative 2? This is kind of like a theoretical time. We're looking in terms of the graph. In situations where we're throwing like a football into the air, then we'll deal with time measurements that actually are more logical. Okay? But for this case, we're just going to go ahead and graph and have the practice of it. What we want to do is set up a 3-row chart, a 3-column if you prefer. And what I'm going to do is basically put each integer. So negative 2, negative 1, 0, 1, 2, and 3. I'm going to plug in each one of these t values to solve for x and y. So if I plug in negative 2, I'll get negative 2 squared. Negative 2 squared would be positive 4. Positive 4 minus 4 will give me 0. Then negative 2 divided by 2 right here to get my y value. That's going to give me negative 1. And basically you continue doing that until you end up filling this entire table, really. So negative 4, negative 3, 0, 5. You can prove that to yourself if you need to. Negative 1 half, 0, 1 half, 1, and 3 halves. Again, I got all of those numbers from plugging in each t value into the respective x and y equations. Okay? So these two together represent this thing called a parametric equation, and we're going to go ahead and graph what this ends up looking like. Right, so based on this function that I have right here, at a certain time, -2, I'm at a certain point. At a time of 3, I'm going to be at a completely different point based on my parametric equation. We're going to go ahead and graph each one. So here, 0, -1. That's when t is equal to -2. Okay, so just to make note, just in case you're confused, these are still x and y. Each point, though, will represent a certain point in time where, my object now is. T equals -1, I'm going to go backwards, -3, then down, -0.5. So that's when t is equal to -1. At t equals 0, I'm going to be at 1, 2, 3, 4. So t equals 0. And now, just so you know, as we're doing this, you might ask, do we have to label each one every single time? It helps because what we're also going to indicate later on is something called orientation, but it's not entirely necessary. I just do this for the first time around. Okay. Finally, the last point, 1, 2, 3, 4, 5, up 3 halves, t equals 2. Okay, so now going in order of my time, I start off at the earliest time, going this way, and then connecting all the way over here.
Oh, you hit the points. Good job.
I did hit the points. Unfortunately, did get a little crooked there. And then now, in regards to orientation of the curves, we're talking about the increasing values of t. So as we're increasing from -2, -1, 0, 1, 2, 3, going up in time, we also got to indicate that we're moving in this direction. Okay? And that would be the parametric equation's plane curve. So this itself is the plane curve. And this was my parametric equation with my parameter. Okay? So all specific terms you're going to need to know. But really all we're doing for tonight and tomorrow is sketching this curve. So as long as you guys can do this part, you're pretty much good to go. Okay? Now there is one thing I did want to show you. In the book, they are going to ask you to use a graphing calculator. Of course, we don't expect you to have it at this point. But the nice thing about having a graphing calculator in terms of graphing these functions is that you get to see it in motion as these two parts of the parametric equation are actually graphed. So I entered it in exactly as we have here. So x equals t squared minus 4, y equals t over 2. I've set my parameters from -2 to 3, my t values there. The t step, if you have a graphing calculator, you can play around with it. But this basically kind of slows down how quickly I go, or you can speed it up as well. So let's go and press the graph button and check out what happens. Just kidding. So let me change it real quick. So let me reset it. There we go. We're going to go ahead and see how this parametric equation moves, the plane curve of it. And basically, as you see it, the parametric equation is being graphed, and that is the curve that's graphed from my parametric equation based on each of the time values. So at a time of -2, I'm all the way down here, just like on my graph over here. And then I can just keep on moving forward in time to wherever these points are. Okay? One thing the book points out that I do want to note as well, you don't need to copy it down, is that the two graphs could look the same, even though they are entirely different functions. So looking over here, I have different x values, different y values, and different times as well. If you notice, this time from -1 to 3 halves, that's a lot quicker than going from -2 to 3. So if I were to actually physically draw this one would have to be drawn a lot quicker than that one. So if I put this one into my calculator right here, this would be graphed quicker than that one, even though they end up having the exact same plane curve. Right? So that's a very quick intro to parametric equations and plane curves. Again, this is really the bulk of our focus for tomorrow. So make sure you understand that. Write down any questions you have. Other than that, have a good day.